one before I take the ACT in April.
Maybe, maybe not. The snow's kind of throwing us off. I'll try.
I'll come
With
see
spring
you.
break, it's going to be kind of rough. Okay, come on back over here. Today I got to teach you something sort of new. It's an expansion on this.
I haven't.
And at this point, everyone is putting this new information into their notes. Okay? Today is March 8th, 2010, and I'm going to steal examples from the book because these are not ones I can make up on my own. There is an element to this unit that is a little bit like, you guys know in PE, you get to the, who remembers the Presidential Fitness Award?
Yeah.
You guys ever do that?
Yeah.
You won? Alright, yeah. You just do push-ups, sit-ups, some chin-ups, that sort of thing.
That's fine.
I was actually testing the kid. I'm
good.
in the PE.
Well, you know,
I was testing them.
okay, well, you know how, name a sport where you actually go out and compete with push-ups or sit-ups, or you actually show a judge push-ups or sit-ups, or do them in front of an audience.
Wrestling practice.
Okay, that's not, you're not actually competing with them, right? So yeah,
You do the
but how many sports use them for practice?
A lot
of them. Okay. This polynomial stuff and something we do in pre-calculus called verifying trig identities are to a certain extent the Presidential Fitness Award of math. They just want to know you can solve these puzzles before they let you try something harder.
But I don't want to try something hard.
Well, that's a different thing, yeah. But it's, you know, you had to do presidential fitness to pass PE. These will work mental muscles that mathematicians find useful. That is a bit of a controversial statement. Just so you know, in parts of Europe, they don't teach problems like this. They actually know, but what they do is they throw the real ones at you and you get the same problem, but it's all with decimals and you've got to figure it out from real examples.
That's awesome.
They give you like a giant, huge word problem on like a rocket launch or something, and they make you use polynomials to solve it. So, depends on what you want to do. Okay. Today we are, all I'm going to do is expand on what we've been doing, and the title of today's lecture is just Factoring Polynomials Continued. And this is when the leading coefficient, bless you, does not equal 1. This is a does not equal sign. Remember how when we were factoring quadratics and all of a sudden if it wasn't 1x squared, every rule we knew went out the window?
Yeah.
Same sort of thing. Okay? If I just make this, again, I'm going to steal one from the book so I'll know the answers. Start with an example. F of x equals 2x cubed plus 4x squared minus 2x minus 4. First, now, Amanda, is this written in standard form with all the exponents getting smaller as we go?
Yeah.
Yes, please double check that. Don't start working with it like this.
Can you like go a little slower because I'm taking double notes?
Sure, I'll go a little slower on this, okay? Here's a short version of today's lecture. This 2 changes things. Okay? This 2 changes things a little bit, and here's how. To use your book's notation, again, I want to make sure I'm consistent with the book. Double check which letter they use for which. They use P and Q, right? Yep. Okay. They call the last number P. And in this case, that's negative 4. They call this new leading coefficient Q. In this case, that's positive 2. Okay, well, they don't really say it's equal. It's a little trickier than that. They say that P are actually can be all the factors of negative 4. And that Q can be all the factors of 2. Where did they get the 2? It's the number in front of the largest, the variable with the largest exponent. The negative 4 is the last number. Okay? Here's the only addition, but it's a biggie. It's the same deal. You need to pick numbers to guess. You need to use synthetic division to see if they can be 0. But now, it is plus or minus all the factors of your last number divided by plus or minus all the factors of the first coefficient. So this makes more choices.
We use all letters or all numbers. Yeah.
Whoops, I'm sorry. That was supposed to be a Q.
Oh.
And that would make it confusing. More so. So what this means is, another way to write this would be plus or minus, what are all the possible factors of my last number, -4, plus or minus 1, 2, and 4, correct?
Yeah.
Divided by all the possible factors of 2, which are plus or minus 2, plus or minus 1 and 2. Those are all the factors of 2. Here's where this gets possibly ugly. We now have the idea of fractions in here. So you have to look at what's 1 divided by 1? 1. What's 2 divided by 1? 2. Not supposed to be a trick question. What's 4 divided by 1? 4. Okay, here's the annoying ones now. What's 1 divided by 2?
Half.
Yeah, just 1/2, 0.5, however you want to do it. What's 2 divided by 2?
1.
1, but we already have that, so we don't have to write it again. What's 4 divided by 2? 2, which we already have, so we don't have to write it again. Okay, so 1, we don't have to write 2 over 2 again because we have 1. We don't have to write 4 over 2 again because we have 2 taken care of. So the only difference in this case is we've got 1, 2, 4, and we have to check the fraction 1/2. Which means your answers could be fractions now.
We don't have to write down the 2 over 2 or 4 over 2, you're saying, right?
No, you know, I'm just letting you know why we did take them into account.
Alright.
Now, in this case, this isn't that much harder. Yes?
How come we never do it for that?
Here's the fun part. We sort of were, but it didn't matter. The same rule applies over here. Really glad you asked that, actually. But in this case, what are plus or minus P over Q? Okay, P is the last number, right? Which we said was 72. So that's all of these possibilities. That's the plus or minus 1, 2, 3, 4, 6, 8, 9, 12, 18, 36, 72. My God, why did they put this in there? And then Q is 1, leading coefficient, over plus or minus 1. So when you divide all of these by 1, you just get the same original numbers. So this rule has always been true, but if this is 1, we could ignore it. If it's 2, we couldn't. If I were feeling really cruel, I would put a problem on the test that would start with 32 and end with like 64.
That's not fast.
No, you'd be testing fractions until you all turn gray. I will not do that. Okay? But now we have to test these things. How does testing a fraction work? It works the same way as everything else we've been doing, but it just, you have to know your fractions when we get to the synthetic division.